From 15 seconds down to 2 seconds. This was an insanely fun performance optimization session that we fully recorded across 2 days, a few weeks before the launch of XHBNL's Shopware 6 shop. Watch me walk through profiling and optimization in real time using Tideways, and I will show my own process, how to optimize performance, identify various bottlenecks, and how in this case they interacted with each other in the worst possible way. Then I optimize each problem away and using different techniques. At the end, the shop is fast and usable, and I'm sure you have learned something along the way. Hi, I am Benjamin, and I help developers solve tricky performance problems with their Shopware, Magento, and PHP applications by providing them with the best profiling data and insights available. And if you need help with your Shopware performance, contact me by clicking on the link in the description. One note, this video sometimes feels a little bit slow watching me think and code. I recommend watching it at 0.25 or 0.5 speed for better enjoyment. Let's dive into this customer's case. Hey, so today you can look me over the shoulder optimizing a Shopware 6 store from a customer who's in dire need of performance improvements. A plugin vendor already helped them optimizing a shared basket feature that they use down from 1 or 2 minutes of time to 10 to 30 seconds. But we are obviously going to need a lot more, and we want to look to make this performance at least around 5 seconds. Maybe we'll get it down even further. The customer is XHB from the Netherlands, and they are selling sun blinds and any kind of thing you can put in front of the window to reduce sun and to avoid being seen through. And from my personal experience working with this kind of companies, they are selling a very complex product. So you will be having a technical support or sales agent coming over. They will going to measure all your windows, all the different configurations, and taking back all those numbers, putting them into one big order of a bunch of different items, one for every window with all the different configurations. And in the case of XHB, they want to move towards using a Shopware shop to do that. And they are currently in the development process. It's not live yet. And the way the process should work is the sales agent would create the basket with all the different items in it, send a link to the customer, and the customer then has all the items in their cart and can check them out. You can already see this in their development system. So we have an example basket here that is shared, and it has 11 products in it, a total price of 3,484. We can use the Google Chrome extension for Tideways to take profiling data, and you can already see it's loading and loading and loading. It will take probably around 15 seconds to do this, because there are a bunch of different plugins used here to implement this sharing functionality and the complexity of the products with all the different things that you can do, that this will overall cause sort of this performance. Let's look at the trace. We can see here 14.7 seconds, and we can already see in the timeline overview that we have the share basket controller, which is loaded here. It takes up 14 seconds in total. And then we have also the checkout controller cart page being called for 6.37 seconds. So it seems that the share functionality, which is a free third-party plugin or even open source plugin, sort of performs some work that takes 7 seconds, or and then another 7 seconds it delegates a call to the cart page. So let's scroll down a little bit to see what's happening here. We can't see too much in the flame graph, which means there are no so you see SQL in pink here. There's no excessive SQL calls, they are all at the end, like in this short span, the last few milliseconds of the request. So there seems to be work done on the PHP level before that needs to be optimized. Switching to the flame graph, we can also see that. So it's not one single operation that makes everything slow here. It's a bunch of different things. Let's see what they are by looking at the call graph. So the call graph first shows that we do have like a lot of SQL statements that are very short. So 1,200 SQL statements for a total of 6.49 seconds. So we would need to find out where they are coming from. The second call here, preg match, with a named sort of regular expression. If we click on that, we see it's originated from doctrine debal SQL parser parse. And this is a regular performance issue that you will see in Shopware shops. And the reason for this is that Doctrine has a feature that allows you to prepare a statement with an array of arguments. And to implement this, it needs to pass the SQL statement for parameter placeholders and look how many array variables it needs to insert there and expand the statement for that. And this seems to happen 375,000 times in this request, which is an excessive amount of times that this method is being called. So we need to find out why this is the case. The second thing that's happening, which is quite unique, a library that I haven't seen before, Wetham's JSON logic. So this method call apply at the iteration, so recursion limit 3 is 612,000 times. So we see there's a lot of recursion going on here. This is the @ symbol represent this in Tideways. So let's look. I've already opened what this JSON logic is. This parser accepts JSON logic rules and executes them in PHP. JSON logic format is designed to allow you to share rules, so some kind of logic, between front-end and back-end code. The way you would, why this kind of library exists is this allows you to share logic between front and back-end in a safe way. So it prevents sort of sharing code with the front end that the front end shouldn't see. And it allows to reuse logic both on front end and back end if it's more complex and dynamic. So this is a port of a JSON library that is written in JavaScript originally. And you can see like an example here. So you see an operation and then the arguments to that operation, and this can be nested quite deep. And this is what is happening here in this Shopware shop. And if we are looking why this is happening and where this is coming from, then let's go through sort of the parents that are being called here. So we're going up the stack trace. Let's close this. We can move faster if we go here. We can see the first time we are using this, and the time for it is like 1.5 seconds, is happening inside the Neon namespace. So the namespace changed and a Neon configurator. And this is a specific Shopware plugin that allows you to build extremely customizable pricing and other logic by putting in these JSON logic formulas for individual products. And this is what HXP is using to implement their very complex sunblind shade products with all the different attributes and variants that they have, like how wide is this project, big, what the different options are. So let's go back to the card here, you see these are all the different options, many different variants, and then also these variants are not individual sort of choice values, but also they're happening sometimes on a scale that can be measured. So this is what this plugin allows HXP to implement inside the Shopware store. However, as we can see, this logic, this flexibility and logic comes at a cost. In this case, 1.5 seconds of JSON logic calculations that are happening on the server. So one thing that we can see and want to optimize at some point. Let's go up the stack trace a little bit to see if it gets vastly slower. So we can see here 1.7 seconds, and then it splits up into different parts of the application that are calling this complex pricing logic, and we will investigate this a little bit later. So let's first, I'll take a screenshot of the calculator service so that we don't forget about that. And I have a Notion document open here, so Neon configurator, JSON formula logic takes a lot of time. Got that? Upload the screenshot, and then we have this. What we can also do is we keep a link to the trace for now so that we can go back to it and reference it later. So this is one thing that we saw. We also saw the doctrine parser, and we want to go back and see where most of the queries are coming from. So we see here, execute, and then what we can see here, this is the first time the query builder code diverges into different paths. So we see the product is fetched 220 times, and then Neon configurations are fetched also for 233. So that's quite some time overall. We make a screenshot for now, and I'm going sort of back this rabbit hole a little bit. Where's this coming from? So products are read from different parts, one from the sales channel repository, then from entity repository search. We are going back here. What we can see here is two parts that trigger this. Fixed installation fee processor. This is probably in the, let's see, the code. Fixed installation fee processor. We can see this is a card processor. So it helps processing the card. And let's see how expensive this one is. So 600. This is custom code. We can see HXP theme card fixed installation fee processor for 600 milliseconds. So that is maybe code that we want to look into because it's the own code of the application. This is very simple to change and optimize. We don't need to talk to Shopware or to third-party plugin providers. We can just improve this ourselves. So let's make a screenshot of that and keep a note for that for later. Going back to the trace. And going deeper again, because during the search we also saw product helper get product by ID. And this is a red flag from my point of view, because On the basket, we see 11 products being in the cart. And if I see product helper get product by ID called 11 times, then I already know this is an n+1 problem because for every product, this method is being called. So let's go and see where this comes from. So we see data layer service get checkout tags 11 times. This comes from a third-party plugin, Google Tag Manager plugin. Google Tag Manager plugins, from my experience, are causing a lot of performance problems in the backend of Shopware stores or Magento stores for that. And it often requires optimizations and changes to make them run fast. So let's go back up a little. And what we can see here is we can see the general subscriber on page loaded of this Google Tag Manager plugin takes 6 seconds. So this is really long time. Let's make a screenshot of that. Also, Google Tag Manager plugin. We haven't really found out why it takes so long because we only found this by accident, this being called 11 times. So let's dive into GA4 service get checkout tags. GA4 service get basket items, product helper sales. And then what we can see here, product detail route load 10 times. So that's confusing because the product detail route object should actually only be used when the product detail page is loaded through the API. So let's look at the code, product helper from this namespace. And look what's happening there. So we see here, get sales channel product entity by product ID. For every product, we are loading this result and then returning the product. Let's see where this is coming from. GH4 service. As you remember, we saw that in the call graph. So let's look at what this function is doing. Get basket items. For a listing, okay, it doesn't have a type here. For a listing, it seems to be an array or iterable of products, product line items. So let's check, get basket, get checkout tags was the method that was being called. So this is nice if you're running with a profiler, then you can exactly see what the runtime is doing and use that information to go through the code view. So we saw get checkout tags for a cart or order. In our case, it's a cart because we're on the cart page. So it says, okay, cart or order get line items, get basket items. It iterates over them and somewhere at the bottom, it calls the product helper get sales channel product. As you remember, this returns a product. They call it sales channel product. And then what it does is, okay, it looks if there's a SEO category on it. And if there's a SEO category on it, it gets the translation name to set item category into the Google Tag Manager e-commerce tracking functionality. So what we can see is that it takes .87 seconds to fill up this array with 10 additional string values, because we are loading the whole product detail route only to fetch the SEO category. And this is obviously a huge performance bottleneck. It's quite wasteful to do that. And I imagine that this didn't happen in tests for this plugin provider, because they only tested it with products that are very simple and don't take a lot of time to load. So it wouldn't take time to load these from the database and perform this operation here. And that means in the usual case, it's fast. However, in this case, for this customer using this extremely complex product, so in combination with the Neon configurator plugin, they sort of interact with each other to cause this very harmful performance. So let's see how we can. So let's see how we can maybe identify what is going wrong in the GA4 service thing. So let's dive into it a little bit to show that this is really happening through the interaction. So product detail route load is called. It calls sales channel CMS page loader. Some events are happening. And then we see on page loaded, on CMS page loaded, the Neon configuration subscriber is interacting. So 4.88 seconds of the 5.2 seconds is just for the Neon lines configuration loading. So we see the interaction here is quite critically slow. And what we could check now is this code actually needed to access the SEO category? So where is the SEO category coming from? Maybe can we access this without triggering the expensive loading of the Neon Lines plugin? So get sales channel, get product load, and we are looking into the product load route. So as you remember, they needed the not the whole response, but only the product. Let's see where the product is loaded. So the product is loaded here through calling the product repository. The SEO category is called here, get product SEO category. So it would be interesting to find out if we can move this code up and load it earlier. So where is the slow code being triggered that makes this whole method slow here? It's triggered here. Here the CMS page loader is loaded. The CMS page loader triggers this event, and there's the subscriber from the Neon Lines configuration bundle on it, and this makes it slow. However, we already have the SEO category here. So if we were able to access this SEO category before, without triggering all the rest of the code, we might get this much faster. So let's take a note on this optimization, and this looks very promising that we might be able to save 6 seconds of time. Let's get back to other code. Specifically the JSON logic code. And I want to also take a note of what we might be able to optimize here. So somewhere in the code, JSON logic apply is being called 610 times from JSON logic rule evaluator apply. And there we have the calculator service calculate with pro mode. with Pro mode. So on the calculation entity, if this is an entity that's provided by the Neon Lines bundle, every product that is configurable has an additional calculation entity in it. If is the type Pro, this method will be called. It then has this method get string formula with replace calculations. And it will create the JSON formula, so the JSON logic. And it will also have context information. And then the rule evaluator is called JSON logic rule evaluator. And this one calls JSON logic apply with the decoded rule and the rule data, which is context information. We also seem to be adding operators here. So whenever apply is being called, it calls add operators. Remember that apply is being called 600 times, and it looks like add operators is something where it adds additional functions, so gross and net calculations, some other additional functions that can be used by this configurator. And why adding them over and over again? In this case, because we also attach the rule data to them, so this way rule data is available. There might be some way to refactor this to prevent calling them over and over again. But that's not actually the performance problem. The problem is the apply here. So we can get into this. And we can see what this is doing. It declares a number of operators. It redeclares, like, remember this is called 600 times, these operators over and over again. So the closures are objects. So what this does is it instantiates new objects, but the rules and the logic here is constant. So what we could do is move this out. And in general, if I see this kind of code, there's definitely there will be some way of optimizing this somehow. So if we look at the repository of the JSON logic PHP, what I do is I look at pull requests to see if some of them optimize performance. And actually I see one here, optimized apply by moving operators into a static array when possible. So let's see, moved out most of the operators array content into a static variable, so the array doesn't need to be defined on each call to apply. Why will this make a difference? If we look at apply, it's called 610 times. But if we look for JSON logic apply, we see it's actually called recursively. And the total number of calls is close to 800, yeah, it's around 810,000 times. So all this time, this array will be redeclared over and over again. And this performance optimization we see here will also make our code faster. So these are two optimizations that we have found so far. And looking back at the timeline, so far we have found the Google Tag Manager plugin, and looking back at the timeline, we can see here that the CMS page loaded event is actually here being called. So what this Google Tag Manager plugin triggers happens within this cart page controller. So the question is still what happens during the share basket controller. So let's make a different kind of approach where we don't go from the bottom up, so looking at the individual functions, finding out where they come from, but instead we are going to the share basket controller and we will try to see what it's doing and dive into if something is maybe inefficient there that we can optimize. So share basket controller does two things. It forwards, and this is what we already know, it forwards to the cart page. So share basket controller load, let's see that. Share basket controller. No, this is from the admin. Share basket controller. There is a load. This is what we're looking at. This is also our route that we see in the page here. So load basket, and we have this share ID. And so we have the cart forward, and then we have the second method being called here, shared basket service decorator load cart. So we see there is code from the HXP theme that is being called here, decorating other code. It's decorating the share basket service. So load cart, share basket service. It's the original code from the Frosh share basket plugin, and then share basket service. Remember, we also have the decorator, and we want to look at that one. So load cart fully overrides the cart loading to include custom line items. Okay, so this looks like the original code was copied and the decorated object is not being called actually. The code is completely replaced for the load method. So let's see, add line items is the one that's causing problems, and then that one calls share basket service decorator add line items, and what that will do is it will cause share basket service add product. So let's look at that. Share basket service add product. It has the cart and the share basket line item entity. So what item is in the shared basket? From that it can get the product ID. It creates a new line item, and then it adds the line item to the cart service. And if we go here and look, the cart service is a Shopware internal service. It receives either one or many items and goes to the item add route. So again here we are calling an API that is accessible from the outside. And let's see it in the call graph to understand it more. So cart service add calls express cart item add route from the Molly Payments plugin, which then calls the decorator cart item add route. This is again a Shopware internal service. And then where it begins locking is in the cart locker. Let's go down there, cart calculator calculate. So 11 times the cart calculator is being called, and the calculator calculates the sum of the cart, applies discounts, and applies pricing rules. However, why do we need to do this 11 times? We already know that we want to add 11 products, and maybe there's an optimization here. Let's see, if we look at this, we have the ability to add multiple items to this cart with one call, and then the calculator is only called once. So what we would be able to do is do not use the cart service this way to insert one item at a time. So the share basket service here is doing this, adding the product one after the time. We could do that at the end for all of the products at once. And that would make this much faster. So what would we save in this time? We would cut down cart item add route time to be called only once. And so I would expect that the performance goes down to not 1/11, but close to that. That would be quite a performance improvement. So again, here we found that a route was called multiple times, whereas we can Frosh basket plugin calls cart item add route for each product once instead for all products at the same time. So let's make off-the-hand calculations what this could improve in the end. We see around 4 seconds that we hope to cut down massively here, maybe even up to 6 seconds. We see this fixed installation fee processor. We haven't looked at that before internally. Maybe 600, we can probably cut this down. The question would be, how often is this part of this call below here, if this is still ending up being a problem after we optimize that. And then we have the JSON formula logic taking a lot of time. So we saw how we can improve the JSON logic library, and we also had the Google Tag Manager code, which we see here, another 6 seconds. So let's say we have around 12 seconds here that we are attacking now with performance optimizations. And if we go back, we see the page here, it took 14 seconds to load. If we can cut 12 seconds down, we would be down to 2 seconds. And for loading a complex cart with 11 items, that's already quite good in my book. And specifically, if we load the page afterwards and see this time, maybe we can see in the profiler again more low-hanging fruits that we can optimize later. Wow, at this point I'm excited. 3 different plugins working together in the worst possible way, slowing each other down to lead to this 15-second result of this shared basket feature of the shop. It's going to be the central feature. A sales agent collected all the information from the customer, provides them with a link to the shared basket so that they can then buy all the products and get their products delivered. And this needs to be fast and enjoyable. Are we going to get the performance down, the 12 seconds estimated, to 3 seconds, maybe 2 seconds? I will optimize the code now, and you can see the results later. Because we are working with the staging environment here, I'm going to first do a quite aggressive prototyping on seeing how we can improve the performance by cutting certain features that we don't need, or sort of simulating that we fixed them already. So remember, the first thing that we can improve is in the product, in the GA4 service, we saw this item category here that was quite expensive. All this code was quite slow. So what we do now is we replace this code to return null for now. And the staging system can be deployed with SCP. So let's upload this file. This is one improvement. Let's go back to the page and reload it. That looked quite a bit faster. We take a look in the profiler as well. Yes, cut this down to 8 seconds, so 7 seconds saved. And now this looks much easier to read and see what the problem is. Specifically, what we can see here now is that we've removed all the time from the card sort of controller part, which we expected. It's like super fast now. And now we can see the card rule loader load, that like loading the card over and over again is another problem here. So how can we fix that? That was fixed in the share basket. It was fixable in the share basket code. So we have add line items here. And this calls add product. Add product then calls, oh wait, this is add decorate. Oh, okay, it calls the private methods of the decorated class. And that is quite the hack. So add product only works. Let's go back, share basket service. Add product. So let's copy this for now to the shared basket decorator. We override it completely. Okay, now this problem is that we need that method to be called. I'm not liking this service being overwritten in this way, but this is a like software engineering problem we would need to look at later. Like from a performance standpoint here, I just want to get this working faster for now, and then maybe we can improve it later. So again, let's get the method. We need to call this one, and we invoke it with these arguments. And product ID. Okay. Product ID, create a new line item, and then something we do different now. Add product. Okay, the problem is that this is an interface. The interface. So my idea would be add product. It returns the line item. And then at the end, we call the card service with the list of line items. However, we cannot really return it here. So let's do one hack where we introduce this products as a workaround. It's actually line items, so let's try to be better about the naming than the code currently is. So we have line items, and now add product was called from add line items here. We iterate over all the line items. In the end, we want to call card service line items, and we can just use it from here. And to make sure that we don't cause a problem, we empty the line items before, if it's called multiple times. So line items only has those in, it iterates over, it adds them here. Okay, maybe we also have additional things here. What to add promotion? Add installation fee. Okay, this one calls this at the end as well. So we need to change that. Line items. And then we also need to copy add promotion to this code here. So Shopware add promotion. Okay, that's quite simple. Decorator. So, and this again here needs to be removed, and line items. Okay, so now the add methods add all them to the line items array, and we call add line items at the end. At the end of the line items method, we call the cart service once. So the benefit of this rather big change now is that we only did it in this one file. So I inlined a lot of code and sort of aggressively made some changes that are not really production ready. But we are here to verify that our performance changes actually make this site much faster. So let's go back to the basket. Okay, this didn't work for some reason. It shows it's empty. So this didn't work. Let's try to find out why. So here we have the problem. Let's throw this errors here. I assume that we don't actually want to do this. Let's see if the original code also does this, because this kind of catching all exceptions and not doing anything about that, it's also doing this. That is quite strange. Okay. Upload. This is also we have an error now. That makes sense. So the exception here is bubbled up. What we can do is look in Tideways what the error is. Okay, so reflection method, invoke argument, object must be of type object, string given, add product. So I assume this is the change I made here. Here. So how does invoke actually work? Again, let's go back and see. Object. The reflection method argument 1 must be of type object, string given. Okay. I think I need to pass this one. But let's look at the documentation. Reflection method. Invoke. Yes. So first the object and then the arguments. So I needed to pass this. Let's deploy the changes and we are going to look again. Here. Fantastic. This looked even faster. down to 5 seconds. Honestly, I've expected a little bit more, but we are going to see what we can do later. So this now looks quite nice already. The cart rule loader is called 4 times. So this might be why it's problematic at this point, but we will see. The time that it takes here is actually insert. So insert into cart is slow. That is something we can probably optimize by looking at why it takes 248 milliseconds to insert into the cart table. But let's look at the core graph and see what is sort of the primary performance problem now. So we still have 2 seconds in SQL statements. So it's the biggest share of things happening. In the flame graph, we can see this is 11% insert, another 10% here, and another 5% here. So 25% is actually the insert into cart. I can also see this in the comment. 31% insert into cart. So that is something that doesn't look too right. But why is it called multiple times? That's something we're going to see. And there's also, you see here the calculations. There's some n+1 problems here where things are being called over and over again. So maybe we can find ways to improve this here. Let's again go to the core graph. We still see the JSON logic code at the top, but what we can see here is through our optimizations, the number of times JSON logic apply is being called was halved. So it's not 600 times anymore, only 360,000 times. This code got faster by not being called from places where it was unnecessary. Most notably the product detail from the Google Tag Manager plugin. So still we can improve quite a lot here, and this is something we are going to try out next. So we have this optimized apply pull request that we want to try out and see if that improves the performance in our case as well. There are multiple ways of doing that. So what you can do is you can fork a GitHub repository that is a composer package, apply the patch, and then overwrite the location of the composer package to point to your fork. The other option is that you can use the composer patches library to apply a patch after you've installed this library. And this is what we are going to do here. The benefit of using composer patches is that you can get upstream improvements of the original library and still always apply your patch until it doesn't apply cleanly anymore. And the downside is that patching can also be a little bit more brittle, because you always need to wait for sort of the installation of the package and applying of the patch to see if it actually works, and then run some tests if the code is doing the correct thing. And this is a little bit more risky than forking the library yourself, but forking requires more time maintaining, and so it's sort of you have to weigh what approach is best here. So the third approach would obviously be to get the upstream library to apply the patch. So this is something that we are going to try afterwards, also to convince the maintainer that the logic is actually working quite well and this change should be applied. So what we do to do this is that we will also make additional proof using Tideways to show how the performance improved applying this patch. So let's install Composer patches. So we'll install version 2.0. So they mention it doesn't work to do that. That's true. We need to say it's the, let's check, is it alpha or did they already release a beta version? Beta 2. Okay, so we want to install beta 2. So we're installing that. Do you trust the region composer? Yes, we trust it. And then we need to go back to the documentation to see how it works. So configuration. So inside the composer JSON, we need to specify a composer patches key. So this is for if you have one patch. But what I do want to do is I want to specify multiple patches. Let's see the composer patches Tideways blog post, because I have a blog post showing how this works. Extra patches, and then we specify name of the patch, what it's for. Okay, let's do that. Composer JSON. We find the extra section there. Patches. We specify which library we want to patch, and that was this one. And then operator perf. And then how do we get the patch? So for every pull request on GitHub, if you open it, you can append .patch to the URL. Then you get the patch. You can copy. And in this case, I put it into custom, a new folder patches, JSON logic operators already. So custom patches, JSON logic operators dot patch. Okay. So now if we run, let's check the Tideways block. Composer patches repatch. We want to run that command. It's fetching this library, patching it. So let's see, JSON logic. We now see that we have a static method build operators here. It saves them in this operators array, and the apply method doesn't do that anymore. It only does it once. So this is the patch applied that worked. So let's see if that improved things. But first we have to deploy them. And because this Shopware shop doesn't have like a proper deployment doing everything in one step, I now have to do that on the server. And I will... and once that's done, we'll continue working on this here. So whenever I'm coming into a project like this, I have to look at how the deployment works. In this case, it's not set up like I would do it. The custom folder is a Git repository that can be deployed, but the rest of the shop system is installed on and managed on the server. So the only way I can update this is uploading it through SCP. I've set this up for this customer, so now I'm going to upload the composer JSON file and the composer log file. I also need to, and I need to push the patches log file and the patches themselves. And we have the deployment here, uploading this. And then on the server, we need to repeat the installation of the composer packages. So we had this here, installation, composer require. And after that, we need to composer patches repatch. And then we generate the trace afterwards. So I'm starting to do something that I forgot before, so I can name the traces so that I can find them later. Oh, okay, that is quite slow now. Slower than expected. You might be wondering if this video is out of order now, going back from 4 seconds to 8 seconds. It's not. Sometimes, if you optimize things, you let another performance problem pop up. In this case, it was a silly mistake I made, and I get back to that in a few minutes. Just wait a little bit and it gets covered. This is not how it worked before. It's doing much more stuff now. Let's check first. We name this applied composer patch 2. JSON logic PHP. We look at JSON logic apply, and it didn't significantly improve. So before it was, I think, also around 800 milliseconds, so the patch didn't do much. Let's look a little bit what's happening inside those methods. So it's calling array map, it's calling isLogic. So let's go deep into JSON logic apply 3. Let's see here. In this case, isLogic is called quite a bit. IsObject. Let's check isLogic. It's calling isArray count. So if you've been following my work, we have composer, no, compiler optimized functions. So it's a feature of PHP engine where if you import a specific list of functions from the global namespace or prefix them with a backslash, it will trigger in the engine specific optimized code to avoid the function call. So let's try do that. We will look at the JSON logic. So what do we have here? So we had isObject. So what we can do is use function is object. Then we also saw is array and count. Is string is also being called here in the logic method. And in the apply method, it's is object is array. Call user func array. We could also improve that, but that's not that much. So it's is array and is string and count. So let's test that on the machine first before writing a patch. To apply that, upload. And run the call graph profiler again. 8.4 and 8.9, it might be unrelated. JSON logic import internal functions. So let's compare this to the previous trace. Okay, that's quite significant. We can see that JSON logic apply, this code is much faster now. And let's check the trace to verify that's really the case. JSON logic apply, yes. Just importing them from the global namespace improved the performance from around 700 milliseconds to 580 milliseconds. So that's a great change. And this is something we need to patch into the library as well later when we clean everything up. So let's look at what happened here and made the trace run slower again. We can see we already have the card rule loader load again. So this is something we fixed already. It seems like it's loading that again. Maybe it was overwritten. I'm going to check that. Okay, I checked, and indeed the change to the share basket service decorator was overwritten in the deployment. So I deployed that again. And now the performance is back to 4 seconds. So I can compare this to a trace from yesterday. Where I didn't have the JSON logic patches applied yet. So now we can see JSON logic apply. And a diff, 200 milliseconds, 228 milliseconds saved for the patch. That's quite great. Okay, let's continue and look for more improvements. So in our document, we now should write what we did as a change. So then the next issue is already highlighted here. H that we found earlier analyzing the slow trace. So we saw that there's a card processor for fixed installation fees. And this is part of the code base. So it's part of the code base of this project, a custom change to the card processor. And we're going to look into how maybe we can improve that. So let's look at a trace with this change. I'm generating a new one. And I'm going to name it before fixed installation fee improvements. And then we are going to look at the call graph, fixed installation fee. You can see we have this one running, and it takes 559 milliseconds. So take a look. Let's take a look at the code. So we have the fixed installation fee processor. At installation fee, it's called 10 times. And then if we go in, we see what this does. It calls entity repository search product 100 times. So that means we have 100 queries to a product. It seems like an n+1 problem that we have here, and that we could optimize. So let's look at the code of the installation processor. So the process method is being called if there is an installation. So if somebody is coming out installing those sunblinds, and this feature is enabled, then add the installation fee. And what it's doing here is iterating over the line items, and then for every line item doing a query on the product repository. So this is a classic n+1 problem in Shopware, and that in this case can be easily remedied by refactoring the code, iterating over the line items. So let's do it this way. We actually want to have the line items first. Product IDs for each line items. We're going over them first. We are fetching the product IDs. And then we are moving this code out here to the top. We don't need that actually. We do need the product IDs array. And then we fetch that, and we don't fetch one product out here that we are doing later. So we keep the product collection, and then here product ID, we removed that before, that we still need that. But we are also fetching this from here. So what did we do? We removed the n+1 by getting the IDs into an array first, making just one query for all the products, and then from this collection it has a get method allowing to access by ID or reference ID, and this way we can add that. So this is just the code refactored a little bit. Deploy this. Again, we are reloading for opcache. It's just this one file that's not in there, but still we want to make sure it's comparable. We take a trace, and that didn't do much. Installation fee. Well, it did something, yeah? So the time was much faster. Maybe something different went slower, so we can't compare the big numbers here. Let's say we name it after fixed installation theme improvement. We're going to compare against the before, looking at the call graph. Installation fee, fixed installation fee. So which one was before, which was after? It looked like it got much slower. Let's investigate what's happening here. So in the before one, we took 599. Let's look at okay. 70 milliseconds. So we did improve by 400 milliseconds. It's just that the traces were hard to compare, I guess. So let's look from the top level how they are looking different. So the card rule loader code got much shorter. So the time improved here quite a lot. If we look at the timeline of this trace, we can see card rule loader load here. And we see the n+1 problem happening so much here. Here it's a bit, no, it's still there. How much does it take in? So 1.85 seconds for the card loader, and here it's 1.8 seconds. It's not improved a lot, so there are different changes making it slower again. Even though we improved the fixed installation rate one, let's create a new trace. Fixed installation rate, okay. So we see the fixed installation rate processor going down by 400 milliseconds, but it's not doing very much to the shared basket yet. So we need to look at more improvements. If we do look at the trace, what stands out is that we still have 2 seconds of time here spent on SQL. So let's take a look at where this happens. So we have insert into card calls here. If we look in the flame graph, it's quite a lot insert card happening at different places. Overall time of this is 37 seconds, percent of the request, sorry. So what happens here is that because the cards have so complex products, and Shopware serializes the object graph into the card, it will have huge payloads, and writing them into an SQL table will take a lot of time. So in a regular optimization, if you see this kind of like performance problem in your code, is that you use the Redis-based card storage. So let's take a look. Using Redis card storage in the documentation. So we have under the performance section a subpage. So on high throughput, this is a problem. It's also a problem in our case where sort of the payload is just very big. So Redis is better built for that. And we can use Redis as a card storage. We have a more recent Shopware version, 6.7 something here. So what we need to do to configure this is using this setting here. And I'm going to do that now on the server. So again, to mention, the Shopware installation is managed on the server directly. So we need to go in there. And I've already found out that the shop is built in a way where the Shopware configuration is in a Z Shopware specific file. So let's open this one up. The only setting it changes is about the admin worker. So let's take the configuration from here. I've already checked before that there is a Reddit instance running on this specific server. So localhost 6379 is the port. DB index, let's go with 0. Let's go with 1 because we might store into the regular config other data that is not as persistent as this one. Then we rerun the cache. So in general, I would definitely rework this application to have a clearer deployment. Because working directly on the machine, since we are just on the staging machine now, we need to replicate everything to the production environment, and that is prone for error. So what I will do now is to actually take that changes that I made here. This is not copy pastable, so let's. And I'm going to copy them over to the documentation that I made so I can make sure. So that's a new bottleneck that we found. Insert card is called often and slow per call using Redis card storage. Config packages that shopware. So we did that, and now we can reload the staging card, see how it turns out. That looked much faster. So let's generate a trace. Down to 3 seconds, 200 milliseconds. That's already an amazing improvement. So what we can see now, and even like there's a session blocking here that should not happen regularly, so that might be an outlier. Let's do another trace. Yes, down to 3 seconds. So let's look at what the problem is right now after all these improvements. We see SQL is down to 380 milliseconds, so that's only a little share of the complete request anymore. So most time spent again is in PHP and not in SQL anymore through the card improvement. We can still see that JSON logic is upon the first calls that are happening here. So JSON logic apply. It's still around 600 milliseconds, 20% of the whole request. So there's still like a lot of things we can get out of this by improving upon this library specifically. But this will probably need much more time understanding how it works, what maybe different handles are here. I could potentially see that you can compile down the JSON formulas to PHP code that gets run instead of like dynamically running the code over and over again. So I think that's a viable thing to do, but that is out of the scope of this improvement plan. So what we can also see is the card rule loader load is still like one of the biggest calls happening here. And specifically, we are seeing an N+1 query for the neon configuration things. If we skip down here, we see like this is like really a big n+1 problem. And this is controlled by this neon configuration functionality here. So let's look where it is. Configurator card handler collect. So collect, then let's see back in the call graph. What was the name? Configurator card handler. Configurator card handler, yes. So we have process and we have collect. Collect takes 1.6 seconds, so that's half of the request, over half of the request. So this is the next step where we can optimize. Configuration loader load with fields. So the configuration card handler collect method is called 10 times. And then it calls configuration loader load with field 10 times for 1.4 seconds. So it seems that it iterates over the configurator line items. Is this really collect run processes? Let's take a look back at the. So whenever card rule loader card is cold, it should run this, but it seems that it only calls them 10 times. So maybe, okay, it caches that. There's a caching code here. So it only does it if it's not calculated led. So that's, it's a local cache. And then for every product, it calls load with fields for just the single product. So let's see how this one looks. Okay, so here maybe we have the n+1 problem again. However, as you can see, it's like a very deep non-ingested query. I'm not even sure it's possible to do that for multiple products at once. However, that's maybe a viable thing we can do and look at as a next step. But from the complexity perspective, I would probably write this up and send it to the plugin authors to give me some idea if this is a workable solution, because like I would be very happy to improve this 1.6 seconds even further. It seems that there is still a lot of gain in there. So let's take stock of what we actually managed to improve here. So let's compare this trace to one of the earlier ones. So we started with 14.8 seconds. Here, 14.6 seconds. These ones. What are the improvements that we saw? We had multiple things that we looked at. So we started with the neon configuration JSON formula logic, taking a lot of time. We applied composer patches. We imported things. The imports are still not persistent, so we still need to adjust the patch to include this information. And then we would need to go to the author and convince them to merge these changes into his library or their library. The second thing we looked at was the HXB card processor for fixed installation fees. So we improved that. and it showed us around 400 milliseconds of improvements. We looked at the Google Tag Manager plugin, and what we improved there is we saw that it loaded 10 times the product detail route. That was happening in GA4 service. And what we did here to avoid this is we comment that out for now. So we still need to work on a viable solution for that. That cut the time into half. So down from, I think, 15 seconds originally to 7 seconds was this step with the first change that we did. We optimized the Frosh Basket plugin, the Share Basket plugin, because for every item in the shared basket, it called the cart item add route once. So the same problem with this one. And we modified that code to call it only once for all the products in the shared basket. And that improved performance down to 5 seconds. So there was a lot of time stored, saved there. And the latest change that we did is we moved to the Redis card storage to make it much faster storing cards that previously were like using this very big and complex product graph and serializing this into a row in the card table would take quite a lot of time because the payload is probably several megabytes big, and that is not something that MySQL can do very well, inserting over and over again. So the improvement is, let's switch the other way around. We can see the improvement is quite big, and now we are going to look in the call graph where we see this. So we saved 6 seconds in SQL statements. We saved time in the DQL code because of executing far less queries, less time in the SQL parser. We improved time in the JSON logic by 400 milliseconds. And then there's like tons of like related changes by avoiding calling lots of code in JSON logic, in hydration of objects. Everywhere we stored a lot, we saved a lot of time because of these changes. So overall, the performance went down from 15 seconds to 3 seconds. So it's an 80% improvement, or we're just taking 1/5 of the time that we took before. And as we saw, there's still a big lever to improve by improving on the JSON logic library and by improving the Neon Lines configuration plugin. Both of those changes take a little bit more expertise, but I'm confident that we will be able to get down to 1.5 seconds with that. And that's a really great improvement. And the customer will be actually able to let customers on their shop now, because previously it was really not usable, waiting over 10 seconds for their basket to load. So we will now clean up the GA4 service fix that we did. So as you might remember, we commented out this line here, and it was used to get a SEO category and save this here into the item category. And I would now want to clean up this and build a patch for it that we can send to the vendor. And the proper fix would be to like remove the product helper or like change the product helper to return the SEO category for us here. And then with the SEO category, we can sort of improve this code here to get the data in a more efficient way. So first, I will revert this change in my Git. So usually for this kind of thing, I create a completely new Git repository, including everything, also the vendor code, so that I can change things everywhere, also in vendor code, and it allows me to make patches to stuff and apply them and provide them upstream. So we have that. So now let's go and do a proper fix for that. So we need to first see, is this method used somewhere else? No, it's only used in this one method. So what we are going to do is we change this here. We want to return a SEO category or null. And we don't actually need this. Let's do it this way. SEO category. What is a SEO category? Let's go back here. Sales channel product. No, okay, I need to go back and return it to its proper. So now I can see it's a category entity. Okay. So we want to change the product helper here to get the category entity. Get sales channel product category, set SEO category by product ID. So now this is SEO category, and then that means if SEO category is not null, then SEO category get translation. Okay. So remember that, so we can change this code now here to inline this change we did before. So this is essentially moving the code. The next step would be to replace the call of this product detail route to directly call the SEO category breadcrumb thingy. Let's give us a little bit more space here. So let's go deep into this code to find out what we needed to have. So SEO category is coming from here. So what we need to do here is call this. We see we need the product. We already have the context. We need the breadcrumb builder. I'm going to keep the style of the plugin authors because then the diff will be smaller. I'm using the shortcut syntax here that makes the diff one line smaller. It's gone here and then this. And then the question would be in the product detail route, how is it getting the product? Product is getting by this call here. Product ID. And we see already there's an n+1 query here. Again, it's something that we can improve probably. Product helper. So criteria. New criteria is here. It's getting it from there. So it gets the product, it gets the SEO category, return SEO category here. That's the code. Product repository is already here, that's nice, so we don't need to include this. Product detail route is not needed anymore. And then we can also remove that, and then maybe let's also change that to, it's weird. Let's do it this way. Okay, that's going to be a bigger diff now. Sorry, I couldn't take that. I need to clean this up a little bit. So, okay. So we have this way, it will fetch that one here, returns the SEO category, and now we entirely skip the product detail route, avoiding all the calls to all the unrelated stuff that we saw in the profiler. We just are interested in the SEO category, nothing else. So can we push this? No, we can't. So again, more stuff to clean up here. Very nice. We don't need that. We don't need that. And we don't need that. And then one thing, but I need to check. Product could also be. What happens if first doesn't find one? Oh, okay, that's a lot of different. Product collection. Entity collection. First. What happens if first has no element? It returns null. Perfect. Okay, so it will return null. So we need to account for this returning null. It's either if no product, then return null. Okay. It's weird how Juni, the JetBrains autoloader, takes use of how people use the code in this project, because in other projects it would definitely do an equals null check here, because it saw more code doing it this way. And this is also the way I would prefer it. Okay, so that is the change we have for now. And this object is defined in the service container. So we need to still modify the service container, resources, config, services, product helper. No. Okay. No, that's not it. Where's the product helper? Ah, okay. It's hidden here in dependency injection. That's interesting. Product helper. Service product helper. Where is it? Ah, in helper XML probably. That's me. Pricing helper, product helper here. We don't need the detail root. Instead, we need the breadcrumb thingy. Argument type service ID category. So now the question would be how to get that. Category breadcrumb. Let's see. I'm trying to search grep category breadcrumb builder in vendor. Okay, it's inlined this way. This is the service ID. Okay, perfect. This should work now. So we modified the helper. Let's check what git status says, what we changed. So the benefit is now we see what files did we change. So those three files, and I'm going to commit them now. However, GA, let's see. Yeah, let's do this change first. Don't use product helper, and I expect the code getting slower now. So we did our improvements. Now we overrode our code that set this to null before. And I'm expecting it to get slower now. Not only slower, it also broke. So let's see what we broke here. Waiting for tideways, product helper. I need to clear the cache. So cleared the cache. This is obviously a problem of the way it's managed in the code, that you can't deploy really the whole project, and it would cleanly install it, clear the cache and everything. It's all done via SCP and live on the server, like you would deploy PHP applications 15 years ago. So that's something that HXP could definitely improve in the future, but it's out of scope for me now. So I'm just working on making that actually fast. So is it still? It seems to be. Yes, there still seems to be an error. D5, breadcrumbs there. That was the error from yesterday. So let's see. What's the problem here still? Given 2 must have been Shopware core framework context. Okay, it's the wrong context. So let's check how was this code before git show. So that's good, because we can now look at the code. So it's the different context. So the question would be, so that, okay, this is not the place where it broke. It passed in the context here. So that seems to be the right context. We're still using that context. Now we are using, it used this context before. Let's try to find out what's going wrong here. Where was the error specifically? Sales channel context given. Okay. That would have been deep in the product detail route. So product detail route. So the original code passed the sales channel context. And for the product repository, it's still the sales channel context here, or not? It appends that here. It's not changing it in any way, I think. Let's see again. Given in product helper line 50. Product helper line 50. Is this one here? So why do we have the wrong context here? We can just do it this way, I believe. Let's and maybe this works. I'm a bit confused because I don't see this in the code being done somewhere. Calling context get context, but now it works. Yeah. So let's do a trace. .9 seconds. So even though we re-added the Google Tag Manager code, it's still the fastest trace we've seen before, so it can't take a lot of time. Let's see. Product helper. Yeah, so our new method, and that's really amazing. It only takes 160 milliseconds. It's still time and that expensive, but remember before calling the product detail route, it took 7 seconds to do that. So that is a massive improvement. And what I saw before is what we can fix now. So we have GA4 service get basket items here. Let's look at that. So we can improve this even further by doing this only once. So we should okay, we can't do it only one. Yeah, at least we can fetch the products only once, but this one does its own query and it only works with one product. But indeed we can improve this to be just, so let's improve that. Just make it one product. That would be amazing. Okay. So what we would do here is we would fetch the products only once. We already have the products here. Oh, it's a line item. Oh, that's I love me some wrong variable names. Okay. Price hammer. If that loads the product, I'm going a little bit bonkers. No, it's not loading the product. Okay. Add category names. Okay, so add category names is something that we do above here. So if add category names, then for each listing as product, and then we do no, just, and now we need to real products. Yeah, that is annoying. So that is actually a line item. So at least in our little code, let's do it that way. And then, oh no, just not remove it. We keep it here. So line item. If it has a reference ID, then real product IDs actually, it need to be called real products IDs. Product IDs. Then if we have real product IDs, then let's perform the query. This one doesn't actually have the product, only the product helper. So let's get products by ID, real products context. Okay, and then now we have real products. And if we don't, then it's null. So let's see the product helper. We already have get product by ID. Let's look where this is used. Data set, get checkout tags. So maybe we can just refactor that to, no, we can't. It's just returning one. Get products by ID, by IDs, product IDs, context. This is, okay, get products by ID. So, okay, get context, get entities. No, do I want get entities? Or, yeah, get entities returns an entity, and then yes, okay, I want get entities. Then I don't actually want the entity, okay. The result returns entities, yeah, entity collection, okay, that's right. Should work this way. So back to this place, get products by IDs, get products by ID, okay. So we have the real products now. Will the real product please stand up? Please stand up. So we don't need that anymore. We do need it. So and real has product get reference ID. If it has, then we want to change this to get the product with the reference ID. Okay, so this code is a bit hard to read, so let's improve it this way. And we change this to actually get the product here, and then so what we need to do is, this is not needed anymore. We move this to the top, and this here becomes a product entity, product this way. Okay. Interesting refactoring. Let's see what. So I always like to review the code. So product helper, we introduced this new method and we changed this to get the product. So that was moving the code around a little bit, and then we needed to change this one to real product IDs. Add categories only if we add the, otherwise it stays empty. And then if it's empty, only if then so it stays null. If we set add category names to false, then real products will be null. And then in this case, real products doesn't match this condition here. Real products it's not filling any value. So, okay. Let's look at status. Only those two files changed. Let's deploy them. Product helper and GA service. And then we deploy that. So I'm only doing this as confidently as I do because this is a staging system. With a production system, we would need to invest much more time into making sure that changes are actually correct. So I'm lucky that that this is a sort of pre-production system where we can do this kind of change, and we can test this immediately. So let's see. GA4 service. Yes, time dropped from 160 milliseconds to 100 milliseconds. So let's name it GA4 product helper n plus 1 after. And we compare it. And there we see the improvement here. Switching them around, we see 58 milliseconds improvement on this code, and that's quite good already. So remember, the original execution through the product detail route was 7 seconds, and now we are down to 85 milliseconds. So what we can do now is we also commit this. I hope you can follow me on the terminal because I made the font bigger so that everyone can read, but that also means it wraps it much more often. That's really a pain to find the right size. Okay, those two files, git commit means remove n plus 1 in GA4 service calling product helper. So I have 2 patches now, and I will send the plugin author those 2 patches. Hopefully they get introduced in their library in the next version. What I would also need to do now is make those patches composer patches, and then remove the commits here, revert the commits again. So the reason is that we want the original plugin code to be unmodified, and we only apply our patches, and so that we can update changes from the plugin vendor. So let's say the plugin vendor releases a new version. In this case, how the shop is built, the new version would override our changes that we had now, and the changes would then the shop would get slower again, and the patch is not applied, so the changes are not applied. So that's going to be something that I will do as a follow-up. But we should now look at different things. Let's go back to our so Google Tag Manager plugin. We built 2 patches to remove use of product detail root, remove n plus 1 of products. Okay. Since this affects other sites on the store, let's try to see how they work. So let's open a category. Going to do a profile of a category, and then we can look at the Google Tag Manager usage there. Navigation controller index. GA4 service. Oh, yeah, it seems to run through entirely different code paths here, not the code paths that we have in the cart. So let's see if we go to the cart. Oh, the cart also loads very fast. So that is an improvement to previously. So all the changes we made directly affect the cart as well. It loads below 1 second. That's amazing. GA4 service. But yeah, get basket items. 450 milliseconds of 800. That's acceptable. Okay, so let's look at what we did. So this is something. Now the Frosh basket plugin calls to cat item root. So this is an open source plugin, so we can do the changes directly there. Frosh basket plugin. Friends Frosh platform share basket. Going to check out the code. We can fork it first. I'm inlining this directly here into the repository. So what were the changes that we did here? So and then I have to go back to one thing that we talked about before. So the project overrode this share basket service. So we have the share basket service decorator in this project. And the decorator, I compared this to the share basket. It actually, what it does is it adds code to allow for additional line items here. So the custom line item. And it also, in add line items, overrides this code from the shared basket service to add this clause here with the add installation fee. So I looked at that and saw that in both cases we have an event, share basket add line item, and also above here is an event, this one. Those two events are actually exactly made to make this kind of changes. So we don't need the decorator. Instead, share basket subscriber. Basket subscriber. Checkout page. That's so I refactored this code out like off screen. Share basket subscriber. I refactored this to have a subscriber for those two events, the required dependencies. Then I have the one method sort of modifying the shared basket line item and one event adding the installation fee. And then I can get rid of the decorator. And the benefit of this is that if we put this into the customer system now, this change, then we can rely on the service from the upstream again. And what did we change in the upstream service? So remember, the problem that we had was card service add being called for every line item. And we want to do it at the end. So we want this code here. Sorry. We want to remove this. So the add line items method should add those, and then it should return sort of here. Call this with all the line items. And the way we want to do this is this. And we want to do it this. So the only thing we have to account for now is my case where I have the event. I throw the event here. So this event needs to change to some degree. Let's see how it works. So we have this kind of things. And now we need for the event to have a method to set the line item. So let's add a private line item and default to 0, to null, 0, okay. And then we also need to add getters and setters here. Set line item, get line item. Thank you, Junie. So our plugin here would need to call this method. So once they update the code and we are using the plugin, then it will only work if we do this here. So what we also need to do here is if we need to store the event actually into a property event. Then if event get line item and then we get the line item. So this is the way we change that. We pass all the line items, and this is the change that will sort of fits the way we did it before. So in our decorator case, what we did, we have the line items here. No, in the add line items code, what we did is we introduced a variable here, a local variable, and we put all the things into the local variable because the methods here still returned void. So maybe let's check here. These, yeah, this show me this is not. It should still return a line item, not void anymore. So we also need to refactor this a little bit. So return null. And then for this case, we also need to return the line item. So line item. And we return the line item. Okay, so let's look at the diff. Status. So we changed this event, we changed this. The event now has the line item as a property, getter setter, and we modified this code to gather all the line items. So here we do need to make an additional change. I remember that we need to check for null. How can we nicely do that? We can array filter this here. Oh, we can check that. I'm wondering if the event should have access to this. I mean, if this previously you were able to, if this is still a product line item, you were able to add even more to that. I think that's fine. I think we need to do it in a way where we array filter. No, actually we don't, because in add promotion, I remember this. This card service, this one still needs to be removed. So, and then we can even improve that to return directly that. More code improvements, and specifically this one doesn't even return. So we also don't need the card anymore, and then we don't need any of that anymore. That it's all falling together. So we don't need the card here. What does it need the context for? Okay, this one. So we don't need to pass the card. And we only need to pass this. And in this case, also we only need to pass the SageCon and the. So only in this case we actually need to check for the null. I don't like it completely, but I'm also fine with it. So, okay, Now, this is the patch now. Changing the branch, B. Card service add once. Only call card service add once with all shared line items. Oh, okay. Git push. Origin only. So. It opens the pull request. Now we can, and this is where it becomes a bit muddy because we don't have a trace to compare this to very nicely. We do have, but I need to find out where it is. This is where being a little bit unstructured sometimes bites you. So where are we with traces? We want trace from yesterday, and we specifically started with traces around 15. Where are they? 14 there. This one's. So this is the slow one. We did the improvement with GA tag things, so that went down to 8. And then we went down to 5. So I think we need to compare this one. Yes, the card rule loader is not called consecutively anymore, so let's make sure we name that one. After frosh basket service n+1. We compare that share basket service add product. Add line items, and then what was the parent method to that? But so this is not showing the improvement based on but I'm okay. So the reason it's showing -5 and then +2 again is because the card service add method was previously an add product and now it's on this level, and it sort of sets itself off to an improvement of 3.5 seconds, which is amazing. Removing the n+1 card calculation in shared basket. Previously, if you have a big shared basket, adding each shared item to the card will trigger the calculation over and over again. With this patch, all shared basket items are added, and then the cart calculation is triggered only once. We tested this with a decorator in a Shopware 6 Shopware shop that had extremely complex product through a second plugin, and the combination of both caused this shared basket load method to take 3 to 6 seconds. With this change, it dropped to just below 1 second. And the bottleneck was moved from this plugin to the other plugin in the dependency chain. So we are uploading the screenshot. Okay, that's great. So that we contributed that change back. We need to contribute the Google Tag Manager change. Let's look at our list. Where are we at? Has side effects with our shared basket subscriber that needs to call event set line item in at installation fee in the future. Okay, so that I read that up because I will send that to the shop developers so they know that this change is upcoming, because otherwise it will break the checkout. So this is already documented and done. We don't need to do any work there. What we do need to do is work on the Neon configurator JSON formula thing. And the JSON logic library is also open source, so we can start working on that a little bit. So opening up the repository, again, we are forking it. Checking out. So this one will actually have, yes, it has unit tests and dependencies. Let's check if we run the unit tests, if this all works. Yes, 600 tests. So this will be a little bit more safe to change. So this is the code that we have before the pull request with the performance changes that we had. Let's go to the original. We already saw that yesterday. there's this optimize function. We applied that patch and we didn't see a big benefit in the performance. However, we saw the improvement using the file imports. So what we want to do is contribute this back. So this is our code that we saw before, and this one is the code that we uploaded directly to the server. So let's apply this. And now we can actually run the tests. Tests will still pass. It doesn't make a difference in this case, definitely. So test running super fast. Check out. Import compiler optimized functions. Optimized functions for big performance gain on large formulas. Where do you want to? Git push origin import there. This is what I want to push. So this is going to be a simple pull request because it's quite straightforward. In a case where we used an excessive amount of large formulas in a script, importing these functions made a 100 millisecond plus difference because the engine could skip calling the internal PHP functions and directly work on opcodes being called in the 100,000s. This matters. So now again, let's see if we can find a trace. So let's filter down to only the basket, Frosh basket load traces. I think we named that one. Hopefully, yes. JSON logic internal functions. Import internal functions. We compared that to applied composer patch. So that to that. JSON logic import functions. We compare them. I hope this is the one that, no, that one doesn't have a call graph. Ah, yes, it was for opcosh reloading. So we need to compare it with this one. So this is where we saw JSON logic apply. Yes, 195 millisecond improvement. Is this the right direction? No, this way around. So we can link to that. And yeah, here we see the methods not being called anymore. That's nice. That's a great improvement. and a good showcase. That project with the use function imports alone. Oh, already done. Okay. Okay, so that's it. Because we didn't measure a big change for this fix here, I cannot really add proof. So one thing I could have done is add proof by showing that's actually true. What was the other thing that yeah. So let's take a look again at what is actually happening here. Maybe we can get some more out of it. The card isn't calling any JSON logic, so let's go back to a shared trace, I guess. Oh, that makes sense. The card has it already calculated and it's stored in the Redis session. Okay. So closure, JSON logic, line 158 to 160. This is not... Okay, I need to repatch this. No, wait. This is in the library. This is what we changed. Okay. 58. Okay, it's this one here. Okay. Apply. Okay, this is the loop where there's no condition left, only values. So maybe we can improve this. So array map here. The difference between the callback being called and calling apply itself, and then the array map, it's 215 milliseconds to 215 milliseconds to 128. And by moving this to a loop, it might be much faster. So we want to return this. So that's one way to find out values. For each values, for each logic as value. Values. I should keep the keys. Pass the value here. What happened here? Where did that come from? Now I'm confused. What was the original code? This one. It generated that code, so that's annoying. Thank you, AI, for confusing me. So let's now look at the clean div, replacing array map with a for each. So that's a change that we also did in Doctrine, where we had a bunch of array maps in the hot pass of code, and they made everything much slower. So if the code is really executed quite a lot, then for each is much faster than array map. And indeed, we see a 267 milliseconds improvement on this code just by removing the array map and replacing it with a for each. So that's going to be another patch that we want to write. So first I want to document this. We need to switch it around, and then we need to show that in JSON logic apply, we don't call array map anymore. Okay. Let's go back to code. Into the JSON logic library. We applied it to our part of the code yet and not to the library. So this is we are inside our import. No, master, okay. New branch, replace array map with for each. Just copying around this code a little bit. And so now this is a much bigger change behaviorally. Test the pass than the import of the use statements. So replace array map with for each. With big performance win. Improves performance. Okay. Is this the right screenshot? Okay, so that is another improvement. And those two patches are now such that we can apply them to the Composer library on the server. So we have this patch here. Remember that we created a patches directory in our code. So what we can do now is JSON logic for each patch. I put it here. I update Composer JSON for each perf JSON logic. What's the name for each? And then we have the second pull request. Patch. So we are going to imply that. Use function patch. Use function, and then we have so. Okay. Let's see if those three patches cleanly apply. Composer patches repatch. It downloads the original, so it reverts all my changes and then reapplies the patches. So let's look at this is the vendor library. It should look like, no, it didn't do that. Ah, yes, I need to composer patches repatch relog composer. I think there needs to be some refresh or something that I need to call. Patches relog is the command I need to call. And now patches repatch. And that tells me no available patcher was able to apply patch logic use function. Patch logic. Maybe, yes, I think I need to remove that. That's not really part of. And then also probably in this case, it needs to look like that. Okay, try again. Yeah. Still not. JSON logic use function. It might break in combination with this, because this also, oh, it actually worked. It changes things there. It might be too close to that one here. But we didn't see this one to make a big difference, so let's remove that for now. try again. Yes. So these two patches for us made a bigger difference. So let's apply those. Maybe let's try if we move that to the bottom. So you can already see the limitations of patching to some degree if you use it a lot. So one thing we could do obviously here is to merge all the patches to one. Patches, relog, repatch. This one applies clear, yes. In this order it applies cleanly. We can also revert those because it actually worked with this. So, okay. So we do have the changes to the patches. So yeah, now we need to push the changes to composer JSON, composer lock, and composer. The patches log file again and to the staging system so that this also applies cleanly. And then make sure that we also push those patch changes to the Git repository of the project where the patches are being stored in the future. Yeah, so, but we've seen like a lot of improvements now. I think I'm extremely happy with the result. So we went down from 15 seconds to now we are down to 2.5 seconds actually. And this is a massive improvement. And we will still be able to see more improvements once we possibly get an improvement in the neon lines configuration bundle, not doing the n+1 queries here anymore. And with that, we should be down, let's say this takes it will still take, let's say 300 milliseconds. We will get down below 2 seconds, 1.5 seconds or something, 1.7, which is amazing for this bigger feature and the complexity of all the rules in there. I hope you had a good time watching me, looking over my shoulder, making these improvements. HXB, our customer, is also very happy with the 15 seconds to like 2-point-something seconds improvement. This store and this shared basket feature is now actually usable for customers, and they can go forward and launch in a few weeks. And I'm wishing them a lot of luck with this like cool and complex store and this setup. And it was really great, like improving it and all these kind of things. I will follow up on the different changes that I made to third-party plugins and potentially doing a blog post and videos out of that as well. Specifically on the JSON logic library, there's a lot of things I can see in the future where we can sort of learn about PHP engine optimizations and certain micro optimizations in bigger code. Are you also in dire need of Shopware Performance optimizations? Follow the link in the description for my consulting help. And if you like this content, you can follow this channel, click the subscribe button, also subscribe to our newsletter. If you also want your Shopware shop to be improved with this order of magnitude, please reach out to me. There's also a link in the description for consulting help from us. Thank you.